All right, so let's look at this next one. We're going to look at a little bit of an application problem. So we've got a polynomial function f of x equals negative 0.27x cubed plus 9.2x squared minus 102.9x plus 400 miles ratio of students to computers in the U.S. public schools in X years after 1980. Use M behavior to determine whether this function could be an appropriate model for computers in the classroom as well as in the 21st century. Okay, so first thing, we got to find out which category of M behaviors this belongs into. So we got to figure out, first off, is it an even or odd function? And then is it even or odd degree? And then second, is our leading coefficient positive or negative? So the degree is 3, so it's odd. And then our leading coefficient, we'll put LC equals negative 0.27. So that would fall into a negative. So remember, odds, they go in different directions. This is an odd negative. So let's go look if we need to. We can go look here. So we're looking at it for an odd negative. Odd negative is right here. So what does an odd negative do? It rises to the left and it falls to the right. So an odd negative rises to the left and falls to the right. So odd negative rises to the left and falls to the right. Okay, now let's talk about the application of this. Okay, so it's rising to the left. So as I go forever to the left, it's rising. And then as I, it does some stuff, but it actually has a couple of turning points. We'll talk about that later. It falls to the right. So now when it falls, think about this on the polynomial, it falls to the right. This thing will continue falling. So let's talk about this as x increases. Now, x is years after 1980. As the years increase, I'll say without bound. So what that means is as the years go on and on and on without bound, so as I go into 2000, 2010, 2020, as I go on forever and ever, the y, which in this case the y, the ratio to of students to computers, of students to computers will decrease because it's falling, okay? Will decrease. Now, think about this. If it falls forever and ever, what's going to happen eventually? Well, eventually, we're going to get into negative numbers. And eventually be negative. And so in this case, would it make sense to have a negative student to computer ratio? No. So the model will break down. So model breakdown will occur. So this model, a lot of these polynomial functions, their model, it works for a certain domain of values. It'll work for some values, but it won't work for long-term values. And so that's kind of the story here. This model might be good for just short term, maybe till 1990, 2000, but eventually this model is going to break down and not be a good representation.